What's up, YouTube? In today's video, I'm going to be introducing to you RabbitMQ. We're going to get started with RabbitMQ. So the idea is that there's nothing on my machine installed with regards to Rabbit. I'm going to show you how to get started with that, and then there'll be some C# code that'll help you use that Rabbit instance, and you'll then be introduced to the C# code on building publishers and subscribers, and we'll go through different models or different scenarios for how to get that all working. So this is going to be a lot of fun. I'm going to keep it simple. So if you haven't ever used RabbitMQ, the steps I do in this video will actually help you get started. I have a Docker image for those of you who use Docker. If you haven't used Docker, I suggest start using Docker because it's really, really simple. And for those who want to install RabbitMQ on the local machine or in a VM, I have instructions for you to do that as well. All the description, all the links will be in the descriptions below. But I'm going to follow these steps of getting started with Docker. All right. It's all on my Docker Hub or GitHub if you're interested. So I'm going to start with the GitHub repo. Go to my GitHub repo. I'll provide the link into the actual repository, but that's the repository. Now there'll be a new one on top of this by the time you see it, but that's the RabbitMQ installation repo. It essentially has a Word document for those of you who want to install Rabbit on the Windows desktop or on a VM. The rest of the files are essentially the stuff I used for producing the Docker image, like the Docker file, the Docker compose, and the RabbitMQ configuration. But if you're using Docker, then just go to my Docker Hub over here. Click on that. That takes you to, I'm hoping you don't have to log in here. All right, so that's my public image, apparently, for my Docker image that I've produced for you here. And if you scroll down just a little bit, you'll see that there is a command line. All right, so I'm just going to copy this command line. Okay, so now if you haven't installed Docker, please install Docker and then start the Docker desktop. That's just like a little UI. And once that Docker desktop has started, you will see this little Docker icon here. If it's still animating, it's still starting, but otherwise you see it says Docker running. You click on that and open the dashboard. I don't have any images currently on my machine here, so the dashboard is showing nothing here. And the idea is by the time you finish installing this Docker image, it will take all of about 30 seconds. And you'll have a perfectly configured RabbitMQ instance running in a container. All right. Okay. So to get that started, once you've installed Docker, start a command prompt in administrator mode, and then paste in the command line. I'm just going to explain the command line parts to you here. All right. So there. So Docker run, of course, is Docker run. I'm exposing a few ports. So the one port I'm exposing is 5672. This is the AMQP protocol port. This is the port you will be using from within your application. So in case you won't see the port because it will use this port by default, what I'm saying here is map the containers port, which is what Rabbit expects instructions to come on, to my local machines. It's the same port number. And then I'm doing the same for the next port, which is the management UI. So as part of RabbitMQ, you can also install the management UI. The image I provided you is based off of another image that already has that built in. So you will have access to the Rabbit UI, and we will be looking at the Rabbit UI in during the course of this video. So the Rabbit UI is mapped to the localhost machines. Localhost machines port 15672. That's the default. So all these port numbers are default. I'm just mapping the containers port to my local machines port. Containers port to my local machines port. Then that's the name of the container I want to provide. When it creates this container, I want it to call it RMQ-matless-container. The containers run detached or in the background, and it's using this image that's available on my Docker Hub. All right. So that's all there is to that. Now I hit enter, and it's basically downloading the image from my Docker Hub, and the Docker Hub image that I provided relies on another image. And so it's using that. And within the next 5 seconds, this thing is going to get done. And that's it. The image is downloaded and the container spun up. If you look at the Docker desktop, you'll see that this is the new container here, and it's running as it's green. You can stop it You can delete it and whatever else, but we're going to leave it as it is. Now, once that's installed and the container is up and running, you should be able to browse to that container using localhost :15672, which is the management UI's port. The image has a default username password of guest. This is an administrator password. You would use it to work through the UI through your application. There's another username and password that I've already pre-configured in the Rabbit instance, and you'll be using that when we look at the C# code. So there are two different usernames and passwords. This one is guest and guest. Guest and guest. Okay, so that's the management UI showing you the Rabbit instance in the container we just created, right? So even though it's localhost, it's really running in the container. And things that I've pre-configured. Let's look at the users over here to start with. This is the new user that I've created, the transcode _ user. I've created an exchange here. There's a virtual host and then the exchange. So virtual host in RabbitMQ is kind of like it's like a partitioning concept. That partitioning could just be like a namespace, if you will, to kind of delineate one exchange from another exchange. Maybe they have the same name, so you're going to have a namespace prefix, if you will. But the virtual host also is a partitioning mechanism in that you can configure the cluster to allocate certain resources for different vhosts or throttle, if you will. So there's all kinds of meanings to the virtual host. So I've created this virtual host. We're going to use that from within our application. And within the virtual host is this exchange called video received exchange. When you're using message brokers, you should be looking at providing or using these brokers for events from your application, right? Things that have happened. So it's like a past tense, right? So video received exchange. It's not video receiving or video going to be received or anything else. So it's always an event that has occurred in your application, and you want other applications, your own or some other teams or some other organizations' applications to react to that event. So always think of things as events. And so you should name your exchanges and queues also as a event name, if you will, rather than something that's happened, like past tense, video received, not video receiving or video going to be received or something like that. All right, so that's the video received exchange. And then I've got a queue predefined for you called video received queue, right? And this is also for the same vhost. So you have to make sure you use the vhost in this case. So they're all part of that vhost. Now, in RabbitMQ and in others, there's a topic or an exchange, and there's a queue, and you have to bind the queue to the exchange. You're going to be publishing messages to the exchange, not to the queue. But you will always publish messages to the exchange. In this case, the exchange has been set up as a fan out, and fan out essentially is just like a broadcast. It'll fan out any message it receives. It's going to fan out to all the queues that are bound to that exchange. So right now we just have the one queue that's bound to the exchange. And the way I've done that, the way you can confirm that is by looking here and look at the bindings. So I've gone to this queue and looked at the bindings here. I can see that this queue is bound to that exchange. I can also look at it from the exchange's perspective. Then go to our exchange, and then you get the bindings here. You can see that this exchange is bound to that queue, right? Now, if I wanted, I can publish a message from here. So I'm in the exchange. I want to publish a message. And let's say some payload. Right. And once I put this in, I can add some properties. There are some well-known properties that Rabbit has, and we look at some of these properties from our code base. These properties are not required, but there are some well-known properties that are considered, let's say, like the header, if you will, of your message, just like in an HTTP. The header information is more like metadata information, and the body is whatever you want to have that in the message. The body is opaque to Rabbit. What does that mean? It means that the RabbitMQ, the message broker, is never going to look at the body. It's not ever going to operate on that body. So you can't ask it to say, hey, if you find this information in the body, then do that. It can't do that. It will never do that. So if you're trying to communicate to the message broker, then you're typically using the header information or properties that are part of that message when you send it, but it's not part of the message body. The message body could be in any format you want: binary, JSON, BISON, BSON, however you want to say that, any format you want. The brokers don't care, right? So here there are some properties we'll be looking at in our code, like the content type. We look at the correlation ID or the message ID is slightly different. A correlation ID is actually quite important. You might use that for situations where, let's say, the user starts their interaction with your system from a browser, and the moment a new user starts an interaction, you associate a correlation ID that's like a unique identifier for that, maybe that session, if you will, or that request response or that request. And then as that request fans out into your app, your enterprises, microservices, if you're using those or services, then every service gets that correlation ID. And so even your message brokers could use the same correlation ID to track messages that it receives, right? So as part of you publishing the message, you can attach that correlation ID as part of metadata here. We'll be using the message ID. That's the unique identifier for a message, and I'll talk a little bit about that. So those are just properties. We'll just ignore that for now. Or simply just post a message to this exchange. Now, there is a queue already bound to that exchange. So when I publish the message here, if I went to the queue here, you'll see there's one message in there. If I go in the queue, I can get the message, and I can tell it to acknowledge the message, which means it'll delete the message once it receives it. So there's one message here. I do the get message. I'll see the message here. I'll see any headers or properties we set up. All that will appear over here. I'm seeing my content or the body in there. And now there's no message left. All right. So this is a simple management UI. It's not fully functional or it's not very intuitive. But when you set up things and you want to just make sure it's all working, you can use the UI to just see that. You can publish messages, receive messages, and all that. And once it's all working and set up, you can then go to C# and do that. So for those who never worked with RabbitMQ, I suggest play with it a little bit, the management UI, and then move to the code. All right, so now let's look at the C# code part of the whole thing here. So this project, I'll just briefly introduce you to the solution that I have. Ignore this project. This project won't be part of the stuff. It's not completed, so it's not like I'm missing anything, but it won't be part of the project upload to my GitHub. It essentially is comprised of two console applications, the publisher and the subscriber. The code here is ready to go with the Docker image that has been installed. During the course of this video, however, we're going to add one more queue, bind it to the exchange, and go through certain scenarios, right? So, but out of the box, this code should work as it is, the code that I upload to GitHub. All right. So the first scenario we're going to look at is a single subscriber to a single queue. All right. So I'm going to have to show you the publisher here. Let me just zoom out again. And in the publisher, you'll see some code here. So let me just explain some of the parts of the code and some parts of the RabbitMQ library. It's very extensive, well-designed .NET library. So there's a lot of documentation on this also. I'm going to highlight some of the sort of the key aspects you should consider, before you start down this path. All right, so the host name is localhost. So this should also work on your machine. The connection factory allows us to create a connection. In this case, we're saying, please connect to this RabbitMQ instance in this location. I'll just break apart some of these things here. So that is the username that I've created here. Then there's a colon, and then there's a highly secured password called password. So this is actually a functioning thing, right? So it's not like I put placeholder. That is the password, the highly secured password. Then at the host name, and then the virtual host, right? So that's just the connection string, if you will. And currently I'm using AMQP to run AMQPS and Rabbit. Of course, you do install SSL, OpenSSL, and certificates and all that. So I'm not going to go through that detail here, but this is fairly well documented. And I don't know if you can get I think there must be a RabbitMQ Docker image that comes pre-installed with certificates, but I don't know for a fact. So anyway, that's separate. Then at that point, you can set the protocol here to be AMQPS. All right. So then we are defined a variable for our exchange, which is the video received exchange. We create a connection, and then using the connection, we create an instance of a channel. So if you can imagine the connection, which is a TCP connection, is from your client application to the server. Think of it as like a pipe. That's the connection. within the connection, there are channels. They're smaller pipes within this one pipe. They're all going to have to go to the same destination, but every channel allows you to have a separate thread of communication with that server, and every channel is full duplex. It's kind of like HTTP2, if you know HTTP2, where you have full duplex channels. So this is the same idea. The channel is not thread safe. If you plan to use a channel from within multiple threads, which is not advised, you're going to have to make sure you employ any mutexes or semaphores that you need to do to serialize access to that channel. The connection is multi-threaded. So within this connection, you can create multiple channels and have them in different threads if that's what you want, but don't share the channels themselves. And that'll just make your lives unnecessarily miserable. All right, so these properties are not required. I thought I just put them in the example here. So this one and this one, these are the properties. None of this is actually required for you to get started, but I've set up certain properties so you can see how to set the properties up and then how to set the values to them. I'm using the app ID, which identifies this application. The content type is text plain. By the way, the content type is, again, it's just hints for either the broker or the consumer. It doesn't mean that you have to have a text plain content type, right? It's not required, but of course you should be consistent. Your header information should be consistent with the body if that's what you're doing. And the message ID, which is just a unique ID for each message. The reason I suggest you use a message ID is because of, if you remember, the quality of service that most message brokers support, which is at least once, at most once, and exactly once, right? So if you get the at least once, it implies that, which is quite common and most typical, it implies that the same message can be given to the subscriber multiple times, which means every subscriber needs to somehow keep a track of the fact that it has processed that message before or not. So this message ID is that, right? You want to use that message ID so you ensure at the subscriber level that before the subscriber acts on a specific message, it looks at that message ID and says, okay, have I ever processed this? Not I as in that singular instance of their subscriber, but for that purpose, has any subscriber processed that message? So that's what that is. The body here is simply just a string. Could be anything. It could be JSON, binary, whatever, or however you want to do that. But as I said, the message body is opaque to most message brokers. They don't care to look inside there, and they will certainly not operate on that. You can't have some sort of a conditional thing that says that the body contains this, do that. All right, so I've got the body. It's a byte array that is actually required when you publish the message. So I'm publishing the message using the channel to that exchange, which is our exchange. No routing key required. As I explained, I'm not going down into the details of what routing keys are. Personally, I don't even like using them. But there's enough documentation on that, on the routing key aspect. The properties are the properties we've set up here, and then the body is the byte array. And that's it. So once the message is sent, this application is in a loop, but it's going to wait for me to press enter to then publish the next message. So essentially, each time I press the enter key, a new message is published. But at startup, it'll publish the one message and then wait. All right. So if I were to run this application, let me make sure this is the startup application and run it. At this point, it has already published the one message. If I look at the management UI for that exchange, or even the queue for that matter, you'll see there's one message in there. Right? If I get this message using the UI here, get the message, you'll see the headers we set up and the message that we set up here. Right? So that's, of course, now the message is, actually it's not gone since I didn't change it to acknowledge. So the message should still be there, right? If I set this to acknowledge, then the idea with acknowledge, if you remember from the, oh, by the way, totally forgot. If you haven't watched my introduction video for message brokers in general, please take a look at that here. This is, it's almost like a prerequisite. I just make assumptions that you watch that video if you don't know what message brokers are. Please watch that video and then come back and watch this video. All right, so now the message is still there, right? And I can now say get the message, but this time act the message. And same message comes back, except this time it's gone. It'll go in a few seconds. I think it'll refresh that. Right, so it's gone, right? So if you remember, the acknowledgement aspect is where you receive a message from the broker, right? And the idea is that what if your subscriber crashes, right? Then that message is lost. So rather than automatically acknowledging the message on receipt, you're telling the broker, give me the message and I'll send you back an acknowledgement. That's the best, most robust way of operating in message brokers, right? There's always a choice. You can acknowledge it as soon as the message broker sends you the message, or you can say, no, don't do that. I will let you know when I'm done. That way you can confirm that you're finished with that job, and then that message is actually removed from the broker. If you don't acknowledge it within a certain time frame, and that can be configured, the message reappears in the queue, and then some other subscriber could actually get it, right? So there's a bit of thought process required in order to make things more robust. All right, now let's look at back to the publisher. As I said, if I hit enter here, it'll publish another message and another message, and you'll see that these messages are all arriving here. 2 messages, another 5 seconds, it'll refresh itself here. There's 2 messages now sitting in the queue. So remember, I'm publishing to the exchange. The exchange itself is is fanning out, as you can see here. It's fanning out to all the queues. Right? That's a fan out exchange. So even though we only have one queue there, and that one queue's got the 2 messages, we are publishing to the exchange. And during the course of the video, as I said, we'll create another queue and see some different stuff happening there. Okay, now let's look at the subscriber. The subscriber is very simple as well. It's almost the same thing. We have the host, which is local host. We have the connection factory creating us the connection where connection strings are exactly the same. We're essentially going to the same broker instance. And again, the connection is used to create a channel. And this channel, then we set up the QoS, or the quality of service. This is where sometimes in some scenarios you have subscribers that process batches of information. So like, the subscribers themselves can handle multiple messages and then can act on each one of those as a batch. So when your QoS can be set to, let's say, 5 messages. And that way it'll only publish the event when 5 messages arrive, right? Because you want to operate 5 at a time. So that depends on your model. In this specific case, I've said that, just give me the 1 message, right? So just give me the 1 message here. And then I'm using the eventing basic consumer. There are various consumers in the library here for RabbitMQ. There is the eventing basic consumer. There's the basic consumer. Both of these are synchronous. And by that, because one is event-based, it's sort of asynchronous, if that makes sense. The non-event based is synchronous, as in it's blocking. So once you say consume, it's going to wait there till a message arrives. So you need to put that in a loop, but it's going to be blocked on that one line till a message arrives, right? Or the batch of messages arrives if you set it up for more than 1 message. Then there's also the async version for the eventing basic consumer. So it's async eventing basic consumer and async basic consumer. So there's both. I'm not doing any work in my event here, but if let's say I was talking to another service or writing to my database, I'd probably use the asynchronous version of the consumer. All right, so we set up this event to receive. Of course, this is asynchronous, meaning the execution is going to go down right down here, and then actually will consume, as in tell the broker that we want to consume messages. This is just the setup of the event here, right? So it's not going to stop here. It's going to come down here and consume, and then it's going to wait on this line over here, right? So we are subscribing to this queue, and of course our exchange is the queue is bound to the exchange, so we don't have to know the exchange in the subscriber. And we are publishing, or we're consuming from that queue. We're saying don't auto-act, so we don't want to acknowledge automatically. And this is the consumer that's going to be receiving the events, and that's the event code, the callback or the event. So here's where we extract all the header information. They're coming to us as byte arrays. That looks a little more complex than it needs to. Of course, you can refactor this code to clean this up a bit. And then the body comes again as a read-only memory generic. So it's a byte array of read-only memory. That has to be converted to an array. So we do that to then convert the array of bytes to a string. and then we have a string. And then we write that message out to the console. And after we've done our work, we then send back an acknowledgement using that delivery tag, which is part of the message that was received here. That's the delivery tag for that message. We're telling the broker, please acknowledge this message, and it's only a single message at a time. And so that's, as I said, both the code is very, very simple. This is not exactly production code, but it's very, very close, mainly because the RabbitMQ library is fairly robust. It does automatic connection, retries, all of that. They can be configured as in retry intervals and things, but it's a fairly robust library. I've never actually had problems with it in production. But there are some things that have to be set up correctly. But this code between the publisher and subscriber, you're all good. Now, so far, we haven't run these two together. So let's run these two together, the publisher and the subscriber, and see how that works. So I don't need that. Okay, let me start up the publisher first. Actually, I'm going to start the publisher from the command line. Okay, so let me navigate to its file. Okay, so that's the publisher. I'm going to run the publisher. One message has already been published. When I run the subscriber now, let me set the subscriber as the startup and run it. It already received the message that was sitting in the queue. So there's 3 messages that we received here. The queue now should be empty. If I look at the queue, there's no messages here. All right. And this is now still waiting for more messages to arrive. So let's use the publisher. Every time I hit enter here in the publisher, we should see a message arrive in the subscriber. Right? So 1, 2, 3, 4, 5, 6, 7, and so on. Right? Now the publishing and the subscription, I've just kept the enter key pressed here, so you can see it's going fairly fast because this is fairly slow. If I didn't have that slowdown in the publisher, it's going to go super fast. You can publish typically on the local machine like this about 6,000 to 8,000 messages a second. And depending on what you're doing in the subscriber and the part that's receiving the messages, even for a simple subscriber like this, remember the subscriber is making 2 calls out, right? It receives messages, but it's also sending back an acknowledgement for every message it receives. So it's a little slower than the publisher. It actually takes about 6 to 8 consumers. This is the competing subscriber pattern. If you have multiple subscribers, and we'll be doing that now for the same queue, right? So right now, this is one subscriber to the one queue. I'm going to spin up another instance or many other instances of this same subscriber, and we'll see what happens with regards to receiving messages. Right? I'll keep the publisher open. I'll keep this subscriber open, but I'm going to spin up more subscribers. So let me do that. Now I'm navigating to the subscribers directory and spin up one more subscriber. Let's spin up 3 subscribers. There are 3 instances of subscribers. Hopefully this is not too confusing. Okay, that's the publisher. I'll keep that here. And then there are 3 subscribers, 2 of these and 1 of that. So these 3 are all subscribers. Okay, so let's put them in a way that you can see all of them. Sorry about the confusion here. Okay, so 1, 2, and 3 are subscribers. And they're all subscribing to the same queue. So these are all competing subscribers, right? There's only one queue so far. And then we are going to publish messages here and from here. So I'm going to start hitting enter here. And let's see what happens on the subscriber side. So published, only the message was seen only in this subscriber. Enter, now it shows up here. Enter, now it shows up there. And there, and here, and here. So it's going in a round robin fashion, right? So you can't determine the order. That's not how you want to write any systems, but multiple subscribers means once a message has been issued to one of the subscribers and it acknowledges, that message won't be given to any other subscriber. You only see the next message in the next subscriber. So that's the competing subscriber pattern. Now, let's look at creating a new queue. I'm going to close all my subscribers here. I can leave the publisher open running since I really don't need to change anything about the publishing part. What I want to do now is we're going to create a new queue manually. Now, all the creating of queues, subscribing, binding, all of that can be done in code, but I recommend you don't do that, especially in production applications. You shouldn't have to have applications have to go create the exchange. That doesn't make sense. But it can all be done in code. I'm going to now do this manually using the management UI. So let's look at that. So I go to my queues, and I want to add a new queue. In this case, I'll just copy the name of this. I want to use the same or similar name here. And I'm going to bind the queue to this vhost. Not bind it, but I'm going to make it in the vhost. I'm going to name this video received notification .queue. All right. So this is video received. I'll probably make this lowercase. No, it's uppercase. All right. And it's durable. And add this queue. So now we have the second queue here, but we haven't bound this queue to the exchange yet. So again, you can go from here and bind it to the exchange. You can go to the exchange and bind it. So in this case, we'll say to the queue, and we'll just paste that. Oh, and so video received notification.queue. And we don't need the routing keys. As I said, I'm not explaining the routing keys part here. Oh, did I make a mistake in the name? Oh my gosh. Okay, I'm going to delete that queue. So delete. And then create a new queue again. So this is do receive dot notification dot queue. Okay, hopefully no spelling mistakes. I'll also copy that. So that's a new queue, video receive dot notification dot queue, and then go to the exchange and add this queue here. Okay, so now we have to the same exchange multiple queues. So one exchange has multiple queues bound to it. Each queue can have one or more subscribers, but we won't do the competing subscribers on this scenario. We'll just have two separate consumers, each one pulling messages from just one of the queues, right? So you have the two queues they bound. So this part is all done. Let's go in here. Now I already have a subscriber that subscribes to this queue name. So what I'm going to do, we'll just go to the binary folder there. Okay, I'm going to copy all of this. And put it all in there. I don't know why I did that. Okay, it doesn't matter. Anyway, so I've made a copy of it here. So this exe is the subscriber and it's subscribed to the previous queue that we had. So I'm just going to run this up here. Right? So that I already have one subscriber for the previous queue. And then in here, I'm going to change the name of the queue. Notification.queue. Right? So when I spin this up, all right, so we have two subscribers to the two different queues. Right? And we pull up our publisher. The publisher is still publishing messages to the same queue, but now we have two different queues, and these are the subscribers to the two different queues. So both of them should receive any messages published to the exchange. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. I want to keep the Enter key pressed here. You'll see that these two subscribers, they're not waiting on each other. They're working completely independently of each other. And the publisher is busy publishing messages here at full speed, of course, with my Enter key pressed here. As I said before, if that publisher went at full clip, I would potentially need 6 to 8 subscribers competing subscribers per queue to be able to consume the messages as fast as you can receive it. So even it's fairly fast. Rabbit is fairly fast. It's not as fast as MSMQ is, but given that there's network communication going on, it's fairly fast. So remember, the acknowledgement is slowing things down a little bit. It's important to use the acknowledgement, and then you do the acknowledgement after you completed your task, whatever that work is on the event received, and then send back an acknowledgement so that you can confirm that that message is finally deleted from the queue only after you finish the work that you were supposed to do in that subscriber, in that consumer. All right, I think this brings us to the end of this video. All the code will be on my GitHub. The chapter markers will tell you at what point I start what part of this topic or this conversation here. And hopefully that helps you get started. So that brings us to the end of this video. I hope you've enjoyed yourselves. I hope you learned a few things. If you have, please give me a thumbs up, and I will see you next time.